So hey guys, this is Dipesh, and in this particular video we'll be talking about a another machine learning algorithm called as k nearest neighbor. Okay, so this it's not very hard. Okay, it's very easy to understand as compared to other machine learning algorithms. Okay, so this will be a very quick video, and in the upcoming next part of this video we'll try implementing this algorithm in Python. Okay, so let's get started. So, so we'll first talk about what is k nearest neighbors. Okay, so k nearest neighbor is a supervised machine learning model to solve regression and classification problems. So up until now, we saw that we saw linear regression, we saw logistic regression, we also saw k-means clustering. So up until now, each particular algorithm was basically solving only a specific type of problem. Okay, for example, linear regression solves regression problems, logistic regression solves classification problem, and k-means clustering basically solves clustering problem. But k nearest neighbor is basically a hybrid algorithm which can solve both regression as well as classification problem. So for example, if you wanted to predict salary given a person's experience, in that case you can use k nearest neighbors. And another example would be, for example, let's say if you want to you want to classify if a email is spam or not. Even in that case, we can use k nearest neighbor. Okay, now uh, now it is heavily inspired by k-means clustering, but it's kind of kind of opposite of k-means clustering, because uh, k-means clustering is a unsupervised machine learning algorithm, whereas k nearest neighbor, okay, k nearest neighbor is basically a supervised machine learning algorithm. All right. So in unsupervised machine learning algorithms, we basically use those to get in more insights from our data. Okay, whereas for supervised machine learning algorithms, we basically you train the supervised machine learning models to do some kind of predictions. Okay, and KNN or k nearest neighbors algorithm is a supervised machine learning algorithm. Now, one main point is that uh, the the uh, the the keyword k. Now, if you have seen the previous video on k means clustering, then you know that in k means clustering, this k is basically a hyperparameter. Okay, so k is basically, let me also write this here. K is a hyperparameter. Now, what does a hyperparameter mean? The hyperparameter is basically a parameter that we have to give to the model before training. Okay, like the model will not choose the model will not find the optimal value of hyperparameter during training. Okay, it is our duty to basically give the value of the hyperparameter before training a model. Okay, so just like knn just like k means clustering, the k in k nearest neighbor is also a hyperparameter. Okay, now, and k is basically a discrete value. Okay, just like k means clustering, k can be anything from 1 to 3. So k can be anything depending upon your data set. Okay, so remember, k is a hyperparameter and it is a discrete hyperparameter. All right. So, so basically, what KNN, basically the general idea behind KNN is based upon the principle that birds of feathers flock together. Now, basically, what it means is, when I say birds of feather flock together, it basically indicates that a particular type of group which has similar characteristics flock together. Okay, so for example, uh, uh, you and your friends, now you and your friends have a lot of you may have a lot of characters and a lot of things in common with you. You know, maybe you are going to a same school, or maybe you like similar things. You know, so the main principle behind KNN is that you try to you take advantage of this similarity between similarity among a particular group. So basically, what I mean is that KNN basically takes advantage of data points being close to each other. Okay. For example, in K means clustering. Let me saw in K means clustering. We saw that data points belonging to a particular cluster have similar characteristics. You know, like they are very close to each other, and maybe they have very similar values. You know, so in K means clustering, we saw that values belonging to one particular group or a cluster are kind of very similar to each other. So now k nearest neighbor basically takes advantage of this principle. So let's see how we can basically use a KNN algorithm to for a regression or a classification problem. Okay. So for example, now this is basically a sample data set which we also used in our regression problem. In this is basically the sample of an employee data set. Okay, so the x variable here, our independent variable here is x, and the value that we are trying to predict is salary. So salary is our y. Okay, let's see how KNN basically let's see how we can use KNN for a regression problem. So now let me clear this. Okay, now the main problem we are trying to solve here is given we want to create a model that will predict the salary of a person given his experience. Okay, so now this is basically this is our data set. Okay, we have five samples. Okay, and each row basically represents one particular employee. Now let's say that we want to predict, let's say we want to do predict the salary for a person whose experience is 6.5 years. Okay, now how will we do this? Okay, how will we do this? If we were to use linear regression, then what we would have done is we would have created a scatter plot. Okay, and we would have tried to find a line of best fit, you know, something like that. But in KNN we don't take that kind of approach. In KNN the approach is very simple. So let me tell you how we'll do this in KNN. So let me repeat this again. So our main problem here is that we want to predict salary given experience, and this is basically a regression problem. And what we want to do is we want to predict the salary of a person whose experience is 6.5 years. So what we'll do is now we'll look for values which are close to 6.5. Okay, so in our example the value which is close to 6.5 would be 5.6. You know, 5.6 is basically the closest value to 6.5, and then another value which would be close to 6.5 would be 3.5. You know, so these two are basically the closest values to 6.5 years of 6.5. Another third value which would be close to 6.5 would be let's take 10. You know, now these three values are very close to 6.5 for in our entire data set. These three values are very close to 6.5. So what we can say is, so what we can do is we can look at their values of salary, and we can try to estimate what would be the value of a person with 6.5 years of experience. Okay, so what we are trying to do here is we are trying to look at data points which are close to this value. Okay, because as I said you that similar data that data points which are close to each other have similar values. you know for example, in this k means clustering problem, we saw that the that data points or samples belonging to one particular belonging to a certain cluster are very similar to each other. So in the same way, 6.5 is close to these three values in our data set. And the reason why we chose 3 here is, we can say that here our k is 3. Okay, k is 3. If our k was 4, or rather if our k was 2, then we would have looked only at two values, and using these two samples, using their values of salary, we would have tried to estimate what is the value of 6, what would be our prediction. So k basically here refers to the number of closest neighbors, okay, the number of closest samples. Okay, so let me clear this again. So let's say that our k is, let's say our k is 3. Okay, now in this case what we'll do is we'll use these three values, and their we'll basically use these three samples. Okay, we'll use these three samples, and we'll try to estimate our own prediction. So here we can see that 3.5 years of experience has a salary of 51,000. Okay, and 5.6 years of experience have a salary of 86,000, whereas 10 years of experience has more than 100,000 salary. So what we'll do is we'll take an average of this. Okay, it's very simple. What we'll do is we'll add them up, and we'll take an average of this. So for example, let me just write this here. So y is equal to 51,000, 51,500 plus 86,700 plus 125,600. Okay, now what we'll do is we'll try to take an average of this, and whatever value we get, that would be our prediction. Let me adjust this. Okay, so let me just open up my calculator, and I will take an average of these three values. Okay, so our after calculating the average, our prediction would be 87,900. Okay, now this would be our prediction here. So what we can do is we can now clear this. Okay, we can remove this, and we can write that our predicted value is 87,900. Okay, so what we did was we looked at the closest data points, and we estimated our prediction here. And you can also see that it's not that wrong. For 5.6 years of experience, the salary is 86,000, whereas for 6.5 years of experience, the salary is 87,000, which is not that bad. Now again, this was an example of solving a regression problem. Okay, now we'll see how we can use KNN to solve a classification problem. Okay, so a quick note here, we use for KNN, we use averaging for regression problems and voting for classification problem. So averaging basically means averaging basically is what we did right now. Okay, so what we did was we found the we found k closest neighbors, and we took their values and we took the average of their values to find to make our own prediction. Okay, so this is basically called as averaging. So whenever you would be solving regression problems using knn, then we will employ the averaging method. Okay, now and whenever you will be trying to solve a classification problem, what you will do is you employ the method of voting. Now voting is also very simple. So let's say that, for example, now this is not regards to knn, this is I'm just explaining you what voting is basically. Okay, how the voting method will work here. So let us say that this is an let's say that this is an image. Okay, let me also write here. Let's say that this is our image, and let's say that we trained multiple models to predict what this image is. So model 1, and let me copy this. So this is our model 2, and this is our model 3. So let's say that we have an image, and we trained multiple models to predict what this image actually means, basically to classify what actually this image is. And for example, let's say this image can either be a dog or a cat. Okay, so basically we are trying to classify if this image is a dog or not, dog or cat, and we have trained multiple models for this. So now let's say given this image uh, one model says that it is a dog. Okay, let me create this. So given this image, let's say first model predicts that it is a dog, and the second model also predicts that it is a dog, but the third model predicts that it is a cat. The third model predicts that it is a cat. Now here, if we employ the voting method, then we can say that the dog class has got 2 votes, whereas the cat class has got only 1 vote. So we'll choose the majority, we'll choose the class with the majority of the vote. So dog has 2 votes, so we'll conclude that the given image is basically a dog. Okay, the given image is basically consists of a dog. So this is basically what we call as voting method. So whenever you're trying to solve classification problem using knn, we employ the voting method. Now another, let me also give you let me actually explain to you how this works visually. Okay, so now, since we are using only 2 features, because we are using 2 features, we can very clearly visualize this. Okay, but if we try to if we choose multiple variables, then we cannot draw knn, we cannot do this kind of visualization. Okay, so that's why, just to keep things very simple, I've chosen only 2 variables, that is salary and experience. So since we have 2 variables, we can easily visualize this on a 2D Cartesian coordinate system. Alright, so let's say that let me just remove this. Okay, let me just remove this. So let's say that you're trying to predict salary. Given experience, and this is basically our scatter plot. Okay, this is our scatter plot. So now if we try to, now let's say that we have a sample. Okay, let's say we have a sample here which we want to predict. Okay, so this blue dot is basically our sample here. Okay, this blue dot is basically a sample we're trying to make prediction for. So what we are trying to do here is we 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 are trying to predict salary for this particular point, given the experience. Okay, so for example, uh, uh, let let's say the salary is somewhere around 5. No, let's say the experience is somewhere around 5 years. Okay, let's say the experience is somewhere around 5 and we are trying to predict the salary, and this is basically our point here. Okay, this is our data point. And now the first thing that what we'll do in knn is we'll decide the value of k. Okay, k means how, basically k refers to how many data points will we consider in order to make our prediction. Okay, or to estimate the value of our prediction. So let's say for simplicity k is equal to 3. Okay, just for the sake of simplicity, k is equal to 3. And yeah, so what we'll do is, now since k is equal to 3, which means that we have to find three closest neighbors to this particular data point, and using those three closest data points we'll try to estimate the value. So what we'll do is, so now let's look for the three closest data points to this particular data point. Okay, so if we look clearly, if we can clearly see that the three closest values to this particular data point are this one. So the first closest data point is this, the second data point would be this one, and the third data point would be this one. So we can clearly see that these are the three closest neighbors to our data point. Now what we'll do is we'll find their value. We'll find what is their actual value. Okay, what is their y label. Okay, what is their y basically, and then we'll add them up, and then we'll take the average of these values, and that average would basically be the prediction for our data point. So here what we did was we found out three nearest neighbors. So this is how basically uh, KNN algorithm works. Okay, now if the value of k was 5, then we would have looked for another two closest data points. So so the ano- other so another two closest data points would be somewhere here. So, so this would be another closest point, and this would be another closest point. So now five we have five neighbors here. K is equal to 5 nearest neighbors. So we can use their values, we can look at their values, and we can try to estimate our own value here. Now if I draw a imaginary cluster here, if I draw imaginary cluster here, then you can see that there is a cluster forming here. Basically you will see that these data points are very similar to each other, and are kind of very close to each other. So we can conclude that since the data points are very close to each other, they tend to have similar values. That's why we can easily use their real values, their real values of y, to predict our own y. Okay, so this is basically how KNN actually works. There is nothing fancy about KNN. It's very simple. So in our next video, what we'll do is we'll try to implement KNN in Python. Now again, the K in KNN is a hyperparameter. Okay, we have to the only way we can find the only way we can find the most optimal value for K is by creating multiple models with different K values and finding their accuracy. Okay, so anyways, we'll do this thing in our next video. I'll show you how we can find the most optimal value for K by drawing a accuracy graph.